Good morning, students. Today we are going to discuss about the chapter sets. Here we can observe different type of colors and their names are also mentioned here. From these colors, if we select some different colors like violet, indigo, blue, green, yellow, orange, red. These 7 colors are collected from the group of these colors. So can you identify what is the common property for these colors and why we have selected only these colors? The common property of these 7 colors is nothing but the colors of rainbow. These 7 colors are the colors of a rainbow. In this way, the collection of the things means like these colors or alphabets or numbers, the collection of the things with a common property or a common rule is called a set, and we can write the set with the braces like this and separating the terms with commas. This is called a set, and each thing in the set is nothing but element. The things in the set are called elements. So here the colors of rainbow is a set. In this set, how many elements are there? Violet, indigo, blue, green, yellow, orange, red. Total 7 elements are there in the set, and all the elements are unique. Let us discuss one more example. Here you can observe the English alphabet. Here letters are from A to Z. Total 26 letters are there. From these letters, now I am going to separate some letters from this list, like these letters A, E, I, O, U. Total 5 letters I have collected. So can you identify what is the common property or common rule behind the collection of these 5 letters? The common property of these 5 letters is nothing but these are the vowels of English alphabet. So these 5 letters have a common property, a common rule, that is these 5 letters are vowels. So we have collected these letters with a common property. So we can say this collection of 5 letters as a set. So vowels of English alphabet is a set, and we can write it like in these braces, and we can separate each element of this set with commas. Okay, so each element in this, each letter in this set is called as element. How many elements are there in this set? A, E, I, O, U. Total 5 elements are there in this set. Let us see one more example. Here you can observe the natural numbers from 1 to 30. From these numbers, I am going to separate some of these numbers like 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. So these numbers are collected from the natural numbers 1 to 30. And can you identify what is the common property or common rule by separating these numbers or by collecting these numbers? The common property of these numbers is nothing but these numbers are even numbers, means these numbers are divisible by 2. So these, the collection of these numbers have a common rule, a common rule or a common property. Therefore this collection is called a set, and we can write these elements in braces like this, and we can separate the numbers of this set with commas like this, and each number in this set is called element. Each number of the set is called element. Then count how many elements are there in this set. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So 15 elements are there in this set, and you can observe all the elements are unique. So we can define the set as a set is well defined collection of distinct objects. Here you have to remember 2 points. The objects, the elements of the set should be distinct, means they occur only one time. The element should be appear in the set only one time. And one more thing, the set is a collection, means it is well defined collection. That means the common property of the collection of the element should be well defined. So a set is a well defined collection of distinct objects, and the objects in the set are called elements. Sets are written by enclosing all of its elements between the brackets. For example, here the collection of elements are there 2 3 5 7 11, and the elements are distinct elements, means they are unique. They appear only one time in the set, and they are separated by the commas, and they are written in the braces. So here, what is the common property of this collection? What is the common rule or property by separating these numbers as a collection? These are the first 5 prime numbers. These numbers are nothing but the first 5 prime numbers. So this is the common property of the collection. So it is well defined. It is saying that you have to select the prime numbers, and the count of the numbers is nothing but 5, and you have to select the first 5 prime numbers only. So the common property is well defined. Therefore this is called a set, means the collection of 2 3 5 7 11 is nothing but it is a set. We can mention it with a name, with any all capital letters from English alphabet. You can write like this: capital A equals to 2 3 5 7 11, like this. And each number from this set are called elements. How many elements are there in this set? 5 elements are there. And if you observe here, the number 3 is there in this set. So we can represent that this 3, the element 3 belongs to, set A. Okay, we can write it in symbolically. Element is 3 and the set name is A. We can write with this symbol. We call it as belongs to. So we can read it as 3 belongs to A. 3 belongs to set A. And one more thing, the number 1 does not belongs to set A. The number 1 does not belong to set A. The element 1 is not there in the set. So we can write it in symbolic way. 1, the element is 1 and set name is A, and we can write the symbol like this. So this symbol represents as does not belong to, and we can read it as 1 does not belongs to set A. And some more examples we can write for this set, like 6 and set A. 6, the number 6 belong to set A or not? So number 6 does not belongs to set A. And the number 7 and set name A, whether 7 exists in the set or not? Yes, so 7 belongs to set A. And the number 10 belongs to set A or not, does not belong to set A? So the number 10 does not exist in the set A. So 10 does not belongs to A. Here some common properties are given. See, observe all months in a year having 30 days. So this is a property. So we have to identify the things which satisfy this common property. So all the months in a year having 30 days. So what are the names of the months having 30 days? April, June, September and November. So these 4 months are satisfying the property, that is these months are having only 30 days. Okay, so the collection of these 4 months is called a set, and we can write these months separating by commas, and we can keep them in braces like this, and we call it as a set. So this is a set of all months in a year having 30 days. We can denote it with a name like capital A or capital B or capital C, anyone. So this is a set. And one more common property is given here, letter in the word madam. So we have to identify the letters in the word madam. So what are the letters are there? M and A and D. These are the letters. Of course, A repeated twice and M are also repeated twice, but we have to take only one time. Okay, so these alphabets M, A, D are following a common property, that these are the letters of the word madam. So we can write this with the separating by commas and keep them in braces like this, and you can write it with, denote it with a name, suppose capital B. So here B is a set and it is having how many elements? 3 elements, M, A and D. You should not write any element 2 times or 3 times like that. Each element should be written only one time in a set. And next, another common property, digits in the Ramanujan number. What is the Ramanujan number? 1729 is the Ramanujan number. So we have to identify the digits in the Ramanujan number. What are the digits in that number? 1, 7, 2 and 9. These are the digits in the Ramanujan number. So these four digits 1, 7, 2, 9 are following a common property, that these are the digits of the Ramanujan number. So this collection is called a set, and we can write by separating them by commas and keep them in braces, and let us denote it by any name of English capital letter, like suppose C equal to 1729. So if we observe here, on the left hand side we have written the common property of the sets. On the right hand side we have written the elements of the sets. On left side we have written only common property, but here we have not mentioned the elements. On the right hand side we have listed the elements of the sets. So writing the common property is nothing but, we call it as a set builder form. Means mentioning or representing a set with its common property of the elements is called a set builder form, and listing all the elements of the set is called a roster form. So we can represent a set in two different forms. One is set builder form and the second one is roster form. Set builder form means we have to mention the common property of the set, but here we will not mention the elements. And roster form means here we will list out all the elements of the set, but the common property will not be mentioned here. So you have to learn the to convert the given set from set builder form to roster form, and from roster form to set builder form. That will be most important topic from this chapter. Before going to learn the conversion of the sets from set builder form to roster form, you need to recapitulate these terms once. So first one, about the even numbers. Even numbers are nothing but the whole numbers which are exactly divisible by 2. So the even numbers are 2, 4, 6, 8, 10, 12 and so on. So these numbers are divisible by 2. For example, you take number 4 and it is divisible by 2. 2 twos are 4 and the remainder is nothing but 0. You take any other number also, 10. This is also even number, so it will be divisible by 2. 2 fives are 10 and remainder is nothing but 2. Divisible by 2 means remainder should be 0 whenever we are dividing it with 2. So the even numbers means you have to remember 2, 4, 6, 8, 10, 12, 14, 16 and so on. Okay, and next odd numbers. Odd numbers means these are the whole numbers that are not divisible by 2. Okay, the numbers which are divisible by 2 are called even numbers, and not divisible by 2 means those numbers are called odd numbers. So here the examples are given 1, 3, 5, 7, 9, 11, 13 and so on. So you can take any number from this. Suppose 5, if you divide it with 2, so 2 twos are 4 and 1 is the remainder. 0 is not the remainder here. That means the number 5 is not divisible by 2. And you take any one number, another number, suppose 7. So let us check it with dividing by 2. 2 threes are 6 and the remainder is 1. So the odd numbers are not divisible by 2. Always they leave 1 as the remainder by dividing 2. So odd numbers means 1, 3, 5, 7, 9, 11 and so on. And prime numbers. Prime numbers, here the numbers are given as 2, 3, 5, 7, 11, 13, 17, 19 and so on. You take any number from this one. Suppose 5 I am selecting. So 5 is divisible by 1 and 5 is divisible by 5. Okay, any another number, suppose 7. 7 is also divisible by 1 and divisible by 7. And 11. 11 is also divisible by 1 and divisible by 11. So what is the property you can observe here? The number 5 is dividing by 1 and the number itself 5. So it has only two factors, and the number 7 is also having only two factors, that is 1 and the number itself. And 11 is also dividing by two numbers only. First number is 1 and the second number is 11 itself. So this is also have only two factors. So how can you define a prime number now? Prime number is a natural number. Okay, it has only two factors, and those two factors also, first one is 1 and the second one is the number itself. Suppose if you take 17, so it is divisible by 1 and the number itself 17. So it has only two factors, means the number prime number will be divisible by only two numbers, that is 1 and the number itself. So remember the first 8 prime numbers, you have to by heart these numbers, the first 8 prime numbers. This will be useful for prime factorization from the first chapter. 2, 3, 5, 7, 11, 13, 17, 19. These are the first 8 prime numbers. And next we have to know about the composite numbers. So in prime numbers, we have seen that the prime numbers have only two factors. So if a number has more than two factors, then the number is called a composite number. So here you can see the numbers 4, 6, 8, 9, 10, 12. Let us take one number. Suppose 6 I am taking. So it is divisible by 1 and also divisible by 6. So it has two factors. But it is also divisible by 2 and also divisible by 3. So the number 6 is divisible by 4 numbers, 1, 2, 3, 6. So it has 4 factors, means more than 2 factors. Therefore 6 is nothing but a composite number. So like that you can take any other number. 10, it is divisible by 1 and also divisible by 10. divisible by 2 and divisible by 5 also. So this number is also having 4 factors. 4 factors means more than 2 factors. So it is called a composite number. So remember, if the natural number having only 2 factors, it is called a prime number, and it is having more than 2 factors means it is called composite number. You can observe here, prime numbers are started with 2 and the composite number started with 4, but 1 is not there in the prime numbers list and 1 is not there in the composite numbers list. So we can say that 1 is neither prime nor composite. 1 is not a prime number because 1 is divisible by only 1. So it has only one factor. As per the definition of the prime number should have two factors. But 1 is having only one factor, so 1 is not a prime number. As per the definition of composite number, the number should have more than two factors, but 1 has only one factor, so it is not a composite number. So we can conclude that 1 is neither prime nor composite, means 1 is not a prime number and also not a composite number. The least prime number is 2 and the least composite number is 4. And in the prime numbers, 2 is the only one even prime number. 2 is the number only even prime number. All other prime numbers are odd numbers. 2 is only even prime number. One more topic about multiples. Multiples means, see, the result of multiplying a given number by an integer. See, for example, the multiples of 5 multiples of 5 means the numbers which you will get in the multiplication table of 5. That means 5 ones are 5, okay, and 5 twos are 10 and 5 threes are 15, 5 fours are 20, like that. The numbers which you are getting in the multiplication table, these are the multiples of 5. So we can write the multiples of 5 means 5, 10, 15, 20, 25, 30, 35, 40, like that. So factors means numbers that divide a given number exactly with no remainder, means remainder should be 0. For example, the factors of 12 are, see, to find the factors of 12, so check by which numbers this 12 will be divisible. So the factors 1, 12 is divisible by 1 and 12 is also divisible by 12. And after 1 you have to check whether it is divisible by 2 or not. So 12 is divisible by 2. 2 6 are 12. So divisible by 2, at the same time also divisible by 6. So we can write here 6. And after 2, 3 table. So 3 fours are 12. So 12 is divisible by 3 and at the same time also divisible by 4. Okay, so these are the factors of 12. These numbers are the factors of 12 that was given here. See, the factors of 12 are 1, 2, 3, 4, 6 and 12. And one more example, we can write like factors of 20 means, so you have to check by which numbers 20 will be divisible. So by one table, okay, 20 is divisible by 1 and 20 is also divisible by 20. And next by 2 table, 2 tens are 20. So 20 is divisible by 2 and also divisible by 10. So this way we can write here 10. And by 3 table, 20 is not divisible by 3. Next by 4 table, 20 will be divisible. So 4 5s are 20. So we can write 4 is divisible 4 and 20 is also divisible by 5. So these are the factors of 20. So factors of 20 are 1, 2, 4, 5, 10, 20. So understand the difference between the multiples and factors. Let us solve this example. Write the following sets in roster form. Means the given sets are in set builder form. Now we have to convert it into roster form. The first one is given as P is the set of all prime numbers. P is the set means the name of the set is P, and we have to write the elements in the braces like that. So what elements we have to take? All prime numbers. What are the prime numbers? Prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, and so on. And you have to take the prime numbers, but that smaller than 10. Smaller than 10 only. So we can write 2, 3, 5, 7. 11, 13, 17, these are greater than 10, so you should take up to 7 only. So the set P is equals to with elements 2, 3, 5, 7. This is the roster form because here we are listing the elements. For the second one, the set name is given as G, so G equals to, and the element should be taken as all the factors of 20. Factors of 20. So 20 factors means we have to write for 20, so it will divisible by 1 table and 20 table, and it will be divisible by 2 table and 10 table, and also divisible by 4 table and 5 table. So the factors of 20 are 1, 2, 4, 5, 10 and 20. And the third one, set of multiples of 5 means the numbers from the multiplication table of 5. So let us take its name as M or any capital letter from English alphabet equals to multiples of 5. So multiples of 5 means 5, 10, 15, 20, 25, 30 and so on like that. But we have to take the multiples by this condition, more than 100 and less than 125. The multiple should be more than 100, okay, and less than 125. So we can write the multiples start from 105, more than 100. So you should not take 100. 105 and 110, 115 and 120. You should not take even 125 also, because he is saying less than 125, not one equal to 125. So the set elements are 105, 110, 115 and 120. So this is the way we have to convert the set builder form to roster form. Means the common property will be given, that is set builder form. We have to convert it into roster form, means we have to list all the elements of that set. Let us solve exercise 2.1. The first bit, which of the following are sets, justify your answer. Means from these questions you have to check whether the collection is a set or not. The first one, the collection of all months of a year beginning with the letter J. The months of a year beginning with the letter J. So the months are January, June and July. So the definition is here very clear. We have to select the months of a year that should be start with the letter J. So here the common property is well defined. So it is a set. This is a set. And we can write the elements like this: January, June and July. Next, second one, the collection of 10 most talented writers of India. So here we have to select the writers of India. Okay, but which type of writers we have to select means the definition is given here as 10 most talented. Most talented means in which way we have to decide the writer as a most talented, whether he should write more number of books or he should write the books in more number of languages, so or he should have more number of uh, followers. So that is not clearly mentioned here. So how can we select a writer as he is most talented? So here the definition is not in a proper way. It is not well defined. It is not well defined. So it is not a set. And the third one, a team of 11 best cricket batsmen of the world. Here also we have to collect 11 cricket batsmen, but the cricket 11 best cricket batsmen. Best cricket batsmen means how to decide a person as he is a best batsman, whether he should make more runs or he should make win more number of matches, that is clearly not defined here. So this is also not well defined and it is not a set. And fourth one, the collection of all boys in your class. So here it is well defined because we have to collect the boys. The boys should from your class, so it is a set because it is well defined. Fifth one, the collection of all even integers. The collection of all even integers. Even means you can take 2, 4, 6, 8 and so on, means divisible by 2. So it is clearly defined, so it is also a set. The second bit, three sets are given here. A with elements 0, 2, 4, 6 and set B with elements 3, 5, 7 and set C with elements P, Q, R. Now we have to fill the appropriate symbol, whether belongs to symbol or does not belongs to, in the blanks. So first one, 0 is an element and A is the name of the set. You have to check whether 0 exists in the set A or not. Yes, 0 exists in the set A. So you have to write here belongs to symbol. That means 0 belongs to set A. In the same way, second one, 3 and set name is C. You have to check whether 3 exists in the set C or not. 3 belongs to actual set B but not in the C. So 3 does not belongs to set C. In the same way, 4 does not exist in the set B. So 4 does not belongs to B. In the same way, 8 also does not belongs to set A, and small p it belongs to set C, and 7 belongs to set B. Third one, express the following statements using the symbols. The element X, name of the element is X and set name is given as A, and you have to write does not belong to symbol between these two. So X does not belongs to set A. It's a symbolic way. Now D is an element of set B. D is the element name and B is the name of the set, and you have to take the symbol for an element means belongs to. So D belongs to set B. Next, 1 belongs to the set of natural numbers. 1 is the element. Natural numbers is also a set. We represent it with capital N. N for natural numbers. So 1 belongs to. So you have to keep the symbol like this. That means number 1 belongs to natural number set N. And next 8. 8 is the element and name of the set is prime numbers P. P for set of prime numbers, and does not belongs to 8 does not belongs to set P because 8 is not a prime number. And fourth one, state which of the following statements are true or false. Justify your answer. First one, here 5 does not belong to set of prime numbers. Here statement refers that 5 does not belong to set of prime numbers, but this is a false because 5 is a prime number. So it should belong to prime number set. But here given that does not belong to. That's why the statement is false. Second one, yes, set is yes with elements 5, 6, 7 implies 8 belongs to yes. It is given that 8 belongs to yes, but actually element 8 does not exist in the set yes. So this statement is also false because actually 8 does not belongs to set yes. Third one, minus 5 does not belongs to W. W means it is a set of whole numbers. Minus 5 does not belongs to whole numbers. Whole numbers means the elements start from 0, 0, 1, 2, 3, 4 and so on. So minus 5 does not belongs to whole number. So this is true. And last one, 8 by 11 belongs to Z. Z means it is the set of integers. But 8 by 11 is a rational number. So 8 by 11 does not belongs to Z actually, but it is given that belongs to Z. So this is also false, because 8 by 11 belongs to rational numbers. It is not an integer. Question number 5. Write the following sets in roster form. Means the given sets are in set builder form. Means the common property is given here. You have to convert it into roster form. Means we have to write the elements of the sets. So first one, B equal to, the set name is given as B. So B equals to, and braces like this, X such that, that means the elements of set B, we don't know the element, so we are considering it as X such that, means the elements X like that. X is a natural number. Natural numbers means we can write from 1 2 3 4 like that, but you have to take the natural number up to, the condition is given here as smaller than 6. So we can write the natural number smaller than 6 means 1 2 3 4 and 5, up to 5 only, not equal to 6, only smaller than 6. Next, second question, C equal to, so the name of the set is C equals to, here also X such that, X is a 2-digit natural number. 2-digit natural numbers means 2-digit numbers will be started from 10, like the 10 11 12 13 14 and so on up to 99. Okay, 2-digit numbers start from 10 up to 99. But you should not write all these numbers. One more condition is given here, such that, means you have to select numbers from these 2-digit numbers, like the sum of its digits should be 8. Means the sum of the 2 digits in the number should be equal to 8. Suppose first number is 10. What is the sum of these 2 digits is 1 plus 0 is 1. The second number is 11. The sum of the digits 1 plus 1 is 2. Okay, in the same way you have to write the, select the numbers, the sum of its digits should be 8. So the numbers are nothing but 17. 1 plus 7 is 8, like that. 26, 2 plus 6 8, 3 5, 35, 3 plus 5 8, 44, 4 plus 4 8, and 53, 5 plus 3 8, 62, 6 plus 2 8, 71, 7 plus 1 8, 80, 8 plus 0 is 80. So these are the elements of the given set. Third question, the set name is given as D. So X such that, X is a prime number. We have to select the prime numbers, but one more condition is also there, which is a divisor of 60. Divisor is nothing but factor. So from the factors of 60, we have to select the prime numbers. So let us write the factors of 60 first. 60 and its factors means 60 is divisible by 1 and also divisible by 60, and 60 is divisible by 2. 2 30s are 60, so it is also divisible by 30, and it is divisible by 3. So 3 20s are 60, so 60 is also divisible by 20. And then next, it is also divisible by 4 table. 4 15s are 60, so 4 15s are 60 is also divisible by 5. So 5 12s are 60, and it is also divisible by 6. 6 10s are 60. So the numbers between 6 and 10, 7 and 8 and 9. So the numbers will not divide 60. So these are the factors or divisors of 60. That is 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, 60. But from these divisors, we have to select only the prime numbers. Okay, so 1 is not prime number, 2 is the prime number, 3 is prime number, 5 is a prime number. So remaining numbers are even numbers, these are not prime numbers. 15 is also not prime number, only these three numbers are there. So D equals to, we can write the elements as 2, 3 and 5. Fourth one, E. The set name is given as E equals to X such that X is an alphabet, means the letter in the word better. So you have to write the letters from this word better. So first letter is B and the second letter is E and third letter is T. You should not T twice, two times you have to not, you should not write, because in the set element should be written only one time. The element should be unique, and E is also repeated, and you have to write only R. So the set name E, so E equals to the elements of set B, E, T, R. And one more question like this, seventh one, write the following sets in roster form. The first one, set A is equals to, here we have to write the natural numbers, but the condition is greater than 50 and smaller than 100. You have to write the natural number greater than 50, not equal to 50. You should not write after from more than 50. So we can start from 51, 52, 53, like that. We have to write the numbers up to smaller than 100, not equal to 100, less than or smaller than 100, means we can write up to 99. Okay, so we can write like this, 51, 52, 53 and so on, 99. And the next one, set B equals to X is an integer which satisfies the square of that number should be equal to 4. Here we have to write the numbers satisfying the condition, means by squaring that number answer should be equal to 4. So we can write the numbers as minus 2 and 2, because minus 2 square is nothing but 4 and 2 square is also 4. So the numbers, the elements in the set are minus 2 and 2. And next, D, set name is D, that X is a letter in the word loyal. So D is equals to, you have to write the letters from this word L and O and Y and A. You should not write L two times. Each element should be written only one time. That is as per the definition of the set. And next one, set name is given as E. So here three conditions are there. You can observe X such that X equal to 2n square plus 1. Okay, but in this, what is n? That is mentioned in the second condition. N value lies between minus 3 to 3. That means n value equal to minus 3. Here n minus 3 less than or equal to is there. Minus 3, minus 2, minus 1, 0, 1, 2, 3, up to 3. And one more condition is also given, n belongs to z, means integer, means you should not take the decimal numbers. Okay, that's why I have written from minus 3 to 3 like this. Now what we have to do, substitute the n value in this formula, 2n square plus 1. So what is the result? The result is x, that will be as an element of the set E. Suppose the formula is 2n square plus 1. If n value is equal to minus 3, then what is the result here? 2 times minus 3 square plus 1. Minus 3 square is 9. 9 twos are 18. 18 plus 1 is nothing but 19. So one element of this set E is 19. Next, if n, next one, n minus 3 is over. Next you have to take minus 2. N is minus 2, substitute in the formula. 2 times minus 2 whole square plus 1. So minus 2 whole square is 4. 4 twos are 8. 8 plus 1 is 9. Now the second element of the set is 9. And next you have to substitute n equal to minus 1. So what we will get? 2 times minus 1 square plus 1. So minus 1 square is 1, 1 into 2, 2, 2 plus 1 is 3. So the next element is 3. And next you have to substitute n equal to 0. So 2 times 0 square plus 1. 0 square is 0, 0 into 2, 0, 0 plus 1 is 1. And the next element is 1. And next we have to substitute n equals to 1. So 2 times 1 square plus 1. 1 square is 1, 1 twos are 2 plus 1, it is 3. but 3 is already written in the set, so no need to write it again. Now n equals to 2. 2 times 2 square plus 1. 2 square is 4. 4 twos are 8 plus 1. This is 9. But 9 already exists in the set. So you no need to write this also. Next, substitute n equal to 3. So 2 times 3 square plus 1. So it is equals to 3 square is 9. 9 twos are 18 plus 1. 19. But 19 is also exist in the set. So here we can close the braces. The set E equals to 19, 9, 3 and 1. It is with 4 elements. Now question number 6. Write the following sets in set builder form. Means the given sets are having the elements. Here listed the elements. Means the given sets are in roster form. We have to convert it into set builder form. Converting it into set builder form means we have to identify the common property or common rule of the elements in that set. The first one is given as 3, 6, 9, 12. What is the common rule for this set? Observe the elements 3, 6, 9, 12. These are the numbers we will get in the multiplication table of 3. So we can write it as x such that, means we don't know the element of the set, so that's why we're writing it as x such that, and we have to explain how the x will be. So x is a multiple of 3, means the number of from the multiplication table of 3. 3 ones are 3, 3 twos are 6, 3 threes are 9, like that. But how many multiples we have to write? Up to 12 only. So we have to mention the condition x such that x is a multiple of 3 but less than 13. Like we can close the set builder form. For the next set, observe the elements are 2, 4, 8, 16, 32. That first number 2 is nothing but 2 to the power of 1, and the second number 4 is nothing but 2 to the power of 2, and the third number 8 is nothing but 2 power 3, and next number 16 is nothing but 2 to the power of 4, and the last number is nothing but 2 to the power of 5. This is the common property of the numbers. So we have to write it in a set builder form. See, x such that x equal to, observe all the elements are in the form of an exponent term. See, base is 2 for all the terms, so we can write x equals to base is 2 and exponents are changing. For the first number, exponent is 1, for the second number 2, third number 3, next number 4 and last number 5. The power value is changing, so let us write it as a variable 2 to the power of n. That element of the set is in the form of 2 power n. Now we have to mention about the n value. N value starts from 1 and ends with 5. So we can write it as 1 less than or equal to n less than or equal to 5. And one more condition we have to add here, n belongs to natural number or integer also you can take, because you should not take from 1 to 5 means 1.1, 1.2, the numbers will also lies in this interval, but we have to take only the integers 1, 2, 3, 4, not decimal numbers, so we have to mention this condition. So in the same way, the third one also you can observe, first element is 5 means 5 to the power of 1, and the second element is 25 means 5 to the power of 2, third element is 125 5 to the power of 3, and fourth element 625 means it is 5 to the power of 4. So we can write it in the set builder form as x such that, here also x is equals to, observe the elements, these are all in the form of exponent function. Base value is 5 for all the numbers, so we have to write here first 5, and the exponent value is changing from 1, 2, 3, 4. So you should consider it as a variable n, and we have to mention about the n. N value starts from 1 and ends by 4. So 1 less than or equal to n less than or equal to 4, and one more condition, n belongs to natural numbers n or n belongs to z also we can write. For the last one, so this first element 1 is nothing but 1 to the power of 2. 1 square is also 1 only. 4 it is 2 square, and for 9 it is 3 square, and for 16 it is 4 square, for 25 it is 5 square, like that, and so on. The last number 100 is nothing but 10 square. So how to write it in the set builder form? So x such that x equal to, so all the numbers are in the form of exponents function. Here base value is varying from number to another number. First number base value is 1 and the base of the second is 2, like that. So you have to mention the base as a variable n, and for all the numbers exponent value is 2 only, same. So write the exponent as 2. That means the numbers are in the form of n square, and here we have to mention about the variable n. N value starts from 1 and ends by 10. So we can write it as 1 less than or equal to n less than or equal to 10, and write one more condition, n belongs to natural number n. In this question, on one side a roster form is given and another side set builder form is given. Now we have to match the roster form with the set builder form. By this way we can match the roster form with the set builder form. Try to solve this one also. Match roster forms with the set builder form. On the left hand side roster form is given, and on the right hand side set builder form is given. You have to match the roster form with the set builder form.